All right, now we're live. Hello everyone, welcome to the office hour for Kyverno. Today we have two reserved sessions where we have Faika and Nitish to give us an introduction to Kyverno-json and the tips for writing policies. And then for the second session, we have the performance regression demonstration from Khaled and how to catch them using the automated workflow. So to start with, let me hand off to Nitish and Feka, if you guys want to introduce yourself briefly, and then we can go ahead and start the session. Please stop share, and you can take it over.
Oh, yeah. Great. Hi, everyone. So I'm Faika Ansari, and I'm an intern at Nirmata. Nitish.
Hi there, everyone. I am Nitish. I am also working as an intern with Nirmata as a policy writing consultant, and we're pretty much excited to show you a pretty exciting tool that is Kyverno-json that is pretty much exciting and does more than what you think about Kyverno. So there are a lot of things that we'll be covering in this session, and I'm pretty much excited for it. So I'll just screen share and so that we can get started. Just let me give it something. I think this looks good. Yeah. All right. Okay. Awesome. So I hope the screen is clearly visible, right? So what are we going to do here is we're going to take a look at what is Kyverno for JSON, or basically the Kyverno-json CLI tool. And a lot of things will be discussed. So first of all, we'll try to understand what is Kyverno-json, right? What is the problem it eventually solves, right? And once we have figured it out, we're going to use how is it different from Kyverno, that is another tool, not another tool, but and then we're also going to see how we're going to write policies for Kyverno-json, and what is the difference factor between Kyverno as well as Kyverno-json, right? Later on at the end, we'll be seeing what is the future for Kyverno-json. So I'm pretty much excited, and without any further delay, let's get started. So first of all, if we go through what exactly is impact of Kyverno, as you already know, everyone, like Kyverno is a CLI tool, and you can use it to eventually validate, mutate your policies. It acts like a what I can say, it acts like a secure guard, so that you don't have any resources that eventually hinders your security inside a Kubernetes cluster. But the thing with Kyverno is that it's Kubernetes native, right? So we need some kind of way that will eventually help us to probably have security when we're trying to write configuration files, probably using Terraform, using Docker, using AWS configurations, and so on for that. So a lot of things is that. So as mentioned earlier, Kyverno is basically Kubernetes native, and Kyverno-json is another tool that is going to be discussed in this slides now. All right. Why Kyverno? You already know about these things, but let's get started and understand what is the difference between Kyverno and Kyverno for JSON. So I'll start with this one. All right. So this is generally the website for the Kyverno-json. You can just hover to kyverno.github.io/kyverno-json/latest. But the first thing that comes here is what is the difference between Kyverno-json and Kyverno CLI tool, right? So Kyverno-json CLI tool is applied to check your securities for each of the configuration files, right? Whether these configurations files are basically by Terraform, whether you're trying to create some resources by Terraform files for your AWS resources, or whether you are trying to create Docker files, right? So Kyverno-json is going to have payloads, right, as a JSON or a YAML format. Generally, we're preferring JSON, but we're going to have payloads of Docker files. Probably we're going to have payloads of maybe Terraform files. we're going to have payloads of AWS configuration files, and we'll provide these payloads to the Kyverno-json, and it will eventually check whether whatever you have specified, whatever you have declared in your policy actually matches with the things, right? So that's what Kyverno-json CI tool, whereas Kyverno is basically Kubernetes native. So it's going to check for specifically resources that are, it's going to check policies related to Kubernetes resources. So for example, I can give you an example. If you go through the home section here, you're already at the home section. So you can see that if you go through the documentation, the first line says it clearly that it extends Kyverno policies to perform simple and efficient validation of data in JSON or YAML format. But here is the main thing. With Kyverno-json, you can now use Kyverno policies to validate Terraform files, Docker files, cloud configuration, authorization requests. Whereas in Kyverno, it was Kubernetes native. So you could only be trying to do these things, right, with Kubernetes resources. Another difference between Kyverno and Kyverno-json is that in Kyverno, you can have mutating policy as well, right? So if you see that a certain resource is not matching your policy rules, you eventually can create a resource, but that's not in Kyverno-json for now. And we're trying to build this feature as well. And probably it will be visible in the future, right? If you go through the introduction, if you go through this thing, I'll show you. If you go through the quick start, here's a very simple thing that has been mentioned, that you're going to create basically an S3 bucket by the Terraform file, right? This is your payload. So we're going to discuss about what a payload is. I think Faika will tell you about more briefly about what a payload is. And these are certain of the commands, but I would highly recommend any one of you who is trying to, learn Kyverno-json, you use Kyverno-json, just go through this quick start guide, and it's pretty interesting. And what is these things, how to write these policies, eventually we'll be discussing that as well in the future. So this is the writing policy section where they have mentioned about, how a policy structure looks like for the Kyverno-json. Also, for a fact, Kyverno-json is what? It's a CLI tool, right? So Kyverno-json is a CLI tool, and you need to basically install it as well. It's going to actually take two things, right? Your payload, right? And your policy. Now, this policy is basically, you can apply it on any configuration file, right? So then you can go through each one of the resources, but that's a basic difference of what a Kyverno is, what Kyverno does, and what Kyverno-json does. So, and we can have existing policies walk through. I think Faika can share how do you go through these policies, what are the policies that we have written so far, and you'd be surprised to know how Kyverno-json works under the hood as well. So Faika, over to you.
I'll share my screen for that purpose. Yeah, so I guess Nitish almost gave us a really good brief about what these things are and how Kyverno and Kyverno-json differs from each other. We saw how much Kyverno has created an impact for K8s resources, and how its policies have helped to basically govern all the K8s clusters and all these things around. Whereas Kyverno-json is doing the same thing for Terraform files, Docker files, and every JSON or YAML payload. So today, let's just walk through all the policies that we've been working on. So going through existing policy structure, I guess we have already navigated through the website. So if you come on the documentation part, you will be able to see the policy structure that we use for Kyverno-json, which kind of differs from Kyverno policies. So in the case of Kyverno-json policy, we have some sections which has its own meanings and differs in meaning and adds a lot of more features, which makes Kyverno-json so versatile that we can apply Kyverno-json policies everywhere. Let's just see into what exactly it is, does it do. So in the policies, if you see, we have API groups. So in case of Kyverno, like we used to use Kyverno as an API version. In case of JSON policies, we are using json.kyverno.io group under API version. And as of now, we only have validating policies in Kyverno-json, but obviously in the future, we are looking forward to also have some or the other mutating policies also. So that's one of the future scope for Kyverno. But right now we are working on validating policies for Kyverno-json, where we will be validating several resources, which include AWS resources and Terraform files, which is basically IAC of AWS itself, and Docker files, and etc. So that's what it is about. The kind is basically validating policy. Then we talk about the metadata. Metadata is obviously what we already know about. So we have the name, annotations, all of this included here. And the main crux is obviously in the specification section. The spec section has certain rules, and under the spec section, we have two criteria which actually governs the entire policy. So what is it? It is the match section and the assert section. We'll come over each of the section moving forward, but I'll give you a brief overview for now. So what we do with the match section is basically we try to filter out which section of our payload do we want to actually make our policy run on. So what do I mean by that? What do we mean by payload? First thing. So when I'm saying that I want to run my policy on a running AWS cluster, let's say. So what we'll do, we'll convert that policy. Let's say we are using Terraform files to build that cluster, and we'll convert that Terraform file into a JSON payload. We'll be able to see how exactly do we convert Terraform files, Docker files into JSON payload moving forward. But we'll convert it into JSON payload, and this is what is a payload against which we will be running our policies. So currently in Kyverno-json, we can run our policy against JSON as well as YAML files. So seeing this, so this has an API version, kind, metadata, and these are all the sections. Then we, okay, so we'll go through this in the next part. The main part of the section, this session has to be what does assertion trees does. So if you see that in Kyverno-json, we use assertion trees. So what does assertion tree does is that we have several sections, like we can decide as to which checks has to pass and which checks can we actually choose between. So we have these two options in assertion trees, that is all and any. So when we define checks basically means which are the which are the things that we need to check in our resource, and then amongst this we just check between the policies that we need. We make a check between those two sections which we have defined in the policy. So that's how things work here. And yeah, so for iterating, we use several modifiers. We'll actually come over it when we go through the hands-on approach. Secondly, let's see the Kyverno policies that we have actually already worked upon. So if you are looking forward to go through these policies and actually inspect them, you can find them on Nirmata/Kyverno policies. Here we have some of the policies already pushed on the GitHub repository. So currently we have worked upon several ECS policies and S3 policies. Let's take one of the examples. So this is Kyverno AWS ECS policy, and I'll go for this one. Let's just keep a brief overview of what exactly is this policy doing and what each section means. So this policy is validating task definitions to check the process ID mode. What are we doing here? It is mentioned in the README that we've written. So this policy is trying to check if a particular ECS task is running on the host process namespace. If it is, then we will try to fail that particular payload. So that is what we're doing. This is a validating policy. And if we go through the YAML and if we go through how exactly do we write the test, we have simply started it all with writing a Terraform file. Now, what does this Terraform file has? This is our way of getting our resource. So this is the way that we are trying to get the resource. This is a Terraform file where we have defined our task definition, and then it has the PID mode set to nothing. So here we don't have a PID mode because this is a good Terraform. Let's take an example of the bad Terraform file. So this is a bad Terraform file that we have written, basically a bad a policy that should fail. So that's what a bad Terraform file is. And we have defined here a resource, a task definition, and the PID mode is set to host, which is obviously what we don't want in this policy. So this policy should fail for this payload. Now, this is the Terraform file. Let's just see. I have cloned this repository and have got this particular file in my local PC. So just let me see. If you're able to see my VS Code. I'm assuming we're on VS Code, all of us. So I'll go through the terminal, and I would like to show you what exactly are we doing here. So this is a version of the same GitHub repository that we were seeing here. And if you find, this is the policy that we have written. We'll go through each section of the policy in a while. Before that, I want to show you how do we start with all this. So we start with writing a Terraform file, which describes the infrastructure. So like I showed this is a resource task definition with the set nothing in this case. And how do we actually create this is that, let's just take this Terraform file outside of this folder so I can show you from scratch. Yeah, over here. So what I am currently having my bat.tf file here in the directory that I am in currently. So now I'll just simply try to generate a JSON payload from this Terraform file. That's how we start. So I am trying to generate a JSON payload. That's for which I will use Terraform tool itself. So this is initializing my Terraform. I'll have to use my profile and everything else. So let's say, all right, I can do this. I'll have to use my profile. Let's see, I have my should skip a minute. Am I supposed to stop the screen for a while? All right, I'll just stop sharing my screen just for a moment so I can configure my AWS CLI.
Sorry for the interruption. I just want to mention that if you can also tell us about how are you going to test this policy, since I think you already have the payloads present locally. So I think that would also be a good option for viewers to understand how are these policies eventually working. What if you change this field to this field? What is going to happen? So you could tell us the approach probably on how did you write it, and what are some of the things that you saw that this field is going to navigate this thing.
Yeah, just a moment. I'll get through the AWS and we'll go through all of those sections. Yeah, now I guess you all are able to see my screen. And I'm just setting up my profile so I can test this thing smoothly. So yeah, I'm initializing the Terraform minute. I hope my screen is visible. Yes. That's cool. So what am I doing exactly is I'm trying to generate the payload from this Terraform file. So how do we do it is, in this case, in case of Terraform, we just use the Terraform command itself. This is initializing, then I'll plan this payload, and from which I'll generate my JSON. It's just it's taking a bit of time. Let's just skip this part. Maybe Ritesh can cover it if you have the bandwidth to do this. But I would just cover of what exactly are we trying to do here. So this is the payload that will be generated if I use the Terraform init command, and after which we can use the section from here. So if you come to the quick start guide, you can see how can we actually generate the payload. So these are the commands. We simply run Terraform init. This is the Terraform resource file that we have written. And then we mentioned from the plan command, we generate a binary through which we just use this command terraform show, and we get a payload in the payload.json format. That is what I have already got here because I ran this already earlier. So this is a JSON formatted payload that I've received, which has the entire infrastructure in the code format. And if you see, it also has the PID mode specification parameter over here. Now I'll just take this code, I'll move it to the playground. Now, what do we mean by playground is that this is one really cool tool that you all can use if you all are testing Kyverno-json or you all want to write policies. So you can use this tool. This is Playground. So where do you find it? You can find it directly on the website, on the Kyverno-json website. When you come here to the Playground section, you can go through Playground. And I'll just paste the payload that we just saw. How do we generate? So I'll paste the payload right here, and the policy that I have already written. We'll go through each section of the policy in the next section of this session itself, while we are seeing how do we write policies. But I'll just give you a very quick brief of what exactly each section over here is doing and how is Kyverno-json working. So this is the API version where we actually define the group of Kyverno-json policy that we're using. So here we are using json.kyverno. The kind is validating policy, like I've already mentioned. And here we have just mentioned the metadata. And coming to the most important section, that is spec, which comprises of rules, which has the match and assertion blocks. Now, what does these two blocks does is that the match block is basically telling that, let's say that this policy is of 150 line, but your work is only with the section which has the ECS task definition PID mode set to host. So you just need to focus on that particular section which has the PID mode set to host. You don't want your policy to run for the entire payload, for your entire infrastructure, obviously, right? So what does the match section does here is that it will narrow down the entire policy and filter only that section for which you want to run your policy. So in the entire policy, what we have kept a match here is for this thing. Now, how do we write this? So that's a very pretty cool thing, because since we are working on these policy for more than a month now, we've been using JMS path expression in our policies. So this thing that you see here, I'll close the other tabs. This thing that you see here is nothing else but a JMS path expression. So JMS path expression in itself is something used for querying JSON that we are using. So over here, I can just simply copy this policy on this page, that is jmspath.org. And now I can start querying which part of this policy do I want to write the policy for. So I'll just see where exactly the PID mode lies. So if you see, the PID mode is over here, which is nothing else but a child of okay, let's just search for exact PID mode. Yeah, this is PID mode. So PID mode is over here, which is a child of values, which comes under resources, root module, and plant values. So I just want to filter down only to this block, which has the resource, right? So that's what we do through JSON policies, JMS path. How do we do is because now I know that it is plant value under which I have. So if we see, do we have plant values here? Yes, we do. So I guess there's some internet connection issue. Sorry. Yeah. So now you see that I'm just querying into plant values. And now if I go under root module, because that is where my PID mode lies. So I just go under root module. Similarly, I'll go under resources because that is where I have my PID mode defined. And then I have my values section. But before values, let's just see. This is where I want to drill down my filter to, just this point. I want whichever is an AWS ECS task definition, all the resources which has this type mentioned, I want to run my policy on those. So I simply use JMS path over here. This is a simple, just don't get overwhelmed because this is just a simple JMS path syntax, which says that I want the type to be AWS ECS task definition, which is mentioned over here. So if this is the type, only then filter it. And you see my policy is now so short. Now this policy will be ran only on this particular payload. So that is what the match section is doing. If you are still wondering what is this path and what is all these things doing, you can just simply hover to JMS path tutorial, and here you'll able to find every single thing that we've been doing. So like if you want to see what functions do we have, like length function and all the other things are just mentioned over here. So that is what we're doing in the match section, which is just filtering down which part of the payload do we want to run our policy on. Similarly, we come down to assertion. Assertion is nothing else but where our actual check lies. So this is where your checks will be there. This is where the comparison will be done with your policy. And it can have multiple check sections, which also has message. And the all basically says that if I can have multiple checks here, so this is entirely a list. I can have multiple checks over here, and I can define several JMS paths in order to write several logics which checks if my policy is what I want or not and get the desired result. So if we have multiple checks, this all makes sure that all the checks are passing. If there is any over here, then any one of the check passes and the policy is a pass. I think that's enough for a brief overview, but I would want Ritesh to go forward and move with explaining you how exactly do we write policy and a quick hands-on approach. Ritesh, over to you.
Yeah, definitely. I hope I am audible this time. Just let me see.
Yeah, you're audible.
Yep. All right. I think I can get started. So now the fact is we're going to look at how are we going to write the Kyverno-json policy. So we have already seen that we have written a policy, and we're also going to check how to test this policy. I mean, what are the things when I say that Kyverno-json is meant for the Terraform files or maybe Docker files, how are we going to use that info? So let's get started, and let me share my screen once again. All right. So I think, yeah. Right, we are now in the writing policy section. All right. If I go through Nirmata/Kyverno policies, you can go through Terraform best practices, because eventually now what I want to do is I want to create my resource from Terraform, as mentioned earlier, and I'm going to scan my policy, okay, that I have got from Terraform using Terraform show command, right? And I want to scan it using Kyverno-json tool, right? So let's assume I'm working on S3 right? So there's this policy called as enable S3 cross-region replication that has a README that mentions how to use this policy, how to get failing checks, how to get passing checks, right? But eventually what it does is, in simple terms, what it does is this policy will fail if it finds that you have not enabled S3, if you have not enabled the cross-region replication in your S3 bucket, but when you're trying to create it using AWS. When you're trying to create it using Terraform file. That's pretty simple. But this is not the only thing. So let's try to understand, like, if you're also planning to write some policies, maybe for your own company, right? How will you do that? So I have already cloned it, and I'll tell you what is the approach that should come behind writing a policy, assuming you're working on enable S3 cross region replication. And you can see, first of all, you have README here, so you can understand what this policy does is, what is this cross region replication. You can always Google it and you can always understand it. But if I go through the test one folder and I see a good terraform.tf file, and the main thing once you're found is that this is the main block that we are trying to use here, is this one, AWS S3 cross region replication configuration. This is the main block. So this will determine whether, okay, yeah, sorry. I think probably, okay. I think let me just, okay. Yeah, all good. So this is a main block that will determine eventually whether our cross-region replication is enabled or disabled. And what is the field? If you go through the Terraform docs, you will understand that status is the field that will determine. So status can have either value as enabled or disabled. Now I want my policy to be something like, if I notice that this Terraform file, whatever payload it gives, and I find that inside the resource, this resource, AWS S3 bucket replication configuration, if I find that status is set to enabled, I'll give passing checks, because that's what I want, right? I want the cross-region replication to be enabled, right? But if I find that this is set to be disabled, right, I want to give failing checks. Now you have written a Terraform file, right? Another thing that you can do here is you need to think of what are the edge cases that you can get for your payload file if you're trying to write a new policy for Kyverno-json, right? So what is going to happen? What is the value of the status if you just remove this block? What is the value of the status then? Will it be present or not? So we have done experimentation and we find that the status will not be there, but by enable cross-region replication will be cross-region replication will be disabled eventually, which means that if this block is not found, we need to give failing checks, right? Another experiment that you can do here is try to understand what if you don't have this rule one? What if you don't have this rule inside the Terraform file? You can see that Terraform itself is giving you error. So it's not worth noting that you're trying to test this edge case as well for your Terraform file. I'm just trying to give you what are the edge cases. You have to think in terms of edge cases, and then you have to generate certain payloads out of it. For example, if you see, I have like one bad payload.json, but you can just modify it accordingly and you can have certain number of edge cases, right? So let's try to understand how we're going to, I'm just going to copy it, right? We're going to write a policy for it now. If I go over to Kyverno, okay, Kyverno-json playground, let's try to write the policy now. Okay. So I'm going to basically do it something, okay, it didn't get copied, okay. All right, cool. So we have the policy, we have the payload here. Payload, you already know how to get it. You can also get it through AWS CLI tool as well. But we have trying to get it from the Terraform itself using Terraform show command. So we're going to first get a binder and we're trying to convert this binder into JSON, right? I think Faika already mentioned about this thing, but this is how it's generally done. Like this is a thing, and this is the command that you generally use to get the payload. This is the payload.json, and this is the JSON that I have payload. I mean, this is the payload. Now, if I go through my payload, I find that here I have used a block in my Terraform file. I have used a block AWS S3 bucket replication configuration, and I want to see whether this status is set to enabled or disabled. If it is set to disabled, I'm going to fill the policy. If it is set to enabled, I'm going to pass the policy. If this block is not found, I know by default it is disabled. How do I know? By going through the Terraform docs and finding what is the value of the status, right? What if I don't use this status? You can't, because it's a required field, right? So this is not an edge case that you can cover. Why? Because Terraform internally is handling this case. All right, if you go through this one, you will find that what is a differentiating factor? Like how are these resources being differentiated, on what basis? These resources are differentiated on the basis of types. Okay, each resource will have different types. No element in a resources array can have same type, right? So they can have different types. So types is that differentiating factor we are going to fetch resources on. And if I scroll down, I find that this is the block that I'm looking for, AWS S3 bucket replication configuration, because this is the block that I have that is eventually containing status field, right? Now I'm going to check in which block is the status there. Like where is the status? If I go down, I see that status is there, but no, this is not what I want. If I go more down, I will see that, okay, I went a little more down. That was not required, but yeah. So this is a type, and I need to see where is status, and you can see that status is set to disabled here. Why? Because I have converted it from a bad payload.json. So this is a bad Terraform file, and I need to write a policy such that I fetch this status and I check. So what are the edge cases that I need to consider? The edge cases is something like this thing. The first edge case that should come to your mind is what if this type does not exist, right? So what if the type does not exist? You know that by default, if this type does not exist, I'm telling you, we researched it, that if this does not exist, it's going to give you failing checks. It means the policy should fail. All right. Other cases, else cases, this type exists. If this type exists, what are you going to do? You're going to check for status. Okay, you're going to check for status. If status has the value as enabled, what are you going to do? Pass the checks. If it is set to disabled, what are you going to do? You're going to fail it. That's the simple thing. These are the three things that I need to keep in mind. But I'm going to write the policy now. So I think one of the best ways is, first of all, you go to the documentation, because that's how the things get pretty interesting. I would personally like to go here through, existing policies that have been written, right? And whenever you're trying to write policies and when you're trying to test it, I would recommend trying to do it by Kyverno-json playground. It's way better. So I'm just going to use like any, and I'm just going to try to understand, not try to understand, but I'm just going to understand, write this syntax. All right. That's it. So under the metadata, we're going to have like something like Kubernetes, the name of this policy. I'll say enable cross region replication, right? And I don't need to provide annotations for now because it's not a compulsory field, but you can if you want. So now we're going to have spec section, and this is a main section. So Faika already mentioned to you about having match block, but let's understand what do we need match block, and I'll tell you why do we need match block at the very first place and when do we not need it. But I would skip the match block for now so that you can get to know later on why do we need match block. But if you know that inside the specs you have a rules, okay, so inside the specs you generally have rules, okay. All right. So inside the rules, what are you going to have? I think inside the rules, you're going to have assert statements. All right. So you're going to have assert statements. Assert means like you're going to make an assumption. And then I think inside the asserts, you're going to have all. So what is this all check doing? All means like it will try to, okay, let me tell you what all does is. So all is going to check for, it means it's trying, it will check for all the checks that are present there. I'll explain it in a bit. So I'm going to have a check here first and then a message for a check. What is this message? So I have done nothing. This is an assert statement. And inside it, we're having all. All means like if we have multiple checks, it's going to check for all the checks. Means it will check that assert will find, what I mean to say is that assert will try to get all the possible checks, all the passing checks. We can also have any here. But I'll tell you what any does. But you generally have an assert, inside it, insert is all, and then you have checks. And this is a message. Message is basically if this check fails, then you're going to specify this message as an error output, sorry. All right. So what is the first case? The first case is the type. What if type does not exist? So let's try to have it now. As like I mentioned, how do you iterate over this one? You already iterate over this one using, this one. This is the thing. So we have something like, planned values, right? And then we have, root module, then we have resources. But if you notice that resources is an array, right? So I need to generally use it. You don't need to use it. But if you notice that resources have multiple types, sometimes the type is this, it has also an element of type AWS IAM policy, IAM role policy, but these are not what we're concerned about. The thing that we're generally concerned about of type this thing. So we're going to filter the resource. How we're going to filter the resource is generally using this syntax. So we're going to say filter that resource which has type equal to something like AWS. Okay, I can just copy it. Okay, let me just, all right. I can just copy it, I can paste it here, right? And then I'm going to use, now think of it, this thing. How are you going to make a check? If left-hand side is true, I want that my right-hand side is also true. That's a passing check. True, right? So you're now going to get a resource type, right? Of type this one. You're going to get an array, right? That's the first thing. You're going to check whether this type exists or not. How can you check it? Once you get a resource array that has a type this thing, because type is a differentiating factor. All right. But you're just getting a resource array from here, right? And this resource array is stored, you can use it in format of @. So I'm going to make a pipe symbol. Pipe symbol generally means something like we're going to, I'll tell you. So whatever the input that you get from here, from the left-hand side, like an array, you're going to pipe it to a function of GMS path, which is length, and then you're going to check its length. Tilde symbol, and then insert. And then I'm going to, this is my expected value. This is a first check that I have written. What I've written is I have tried just to write something like I'm going to check whether this type exists or not. If it exists, try to find if it exists. How am I going to try to find it? If it has a length, if you are getting an array element, it means it has a specific length. If it has a length, it is minimum 1, right? So I'm going to check if you're getting something from here, it means the length will be 1. it will be greater than 0. It means this side will be true. And I am expecting this to be true, right? So my true is going to give me passing checks. That's how I'm going to figure out whether this type exists or not. But maybe we can be wrong here, right? So I'm going to just cut it here. And let's see if this works. Awesome, this works, right? But what if this is not present? What if it is not present? I'm going to change configuration to configurations. Run, it's failing. Why? Because now the configuration is not present. All right, this is the first thing we have resolved now. What was the first thing? The first thing that we resolved was basically that checking whether type exists or not. We know that now. If a type does not exist, we know that if type does not exist, then the status is set to be disabled by default and a policy should return failing checks, and it has returned. But now you might ask me, what is this message does? Message is going to be returned when a policy check fails. So I'm going to say this block doesn't exist, right? If I run it, you get the message, this block doesn't exist. That will tell the user, right? Which block does not exist, you can modify always this message. All right, we're going to have another check statement now, because now we're going to have another check statement, something like this thing. So let me just check. And now here is something different. So the first time we have checked something like we're just checking whether this is present or not. But now we know that if it is present, we're trying to iterate inside this resource area now. We're trying to iterate inside this specific resource array element of type AWS S3 bucket replication configuration. So in order to iterate it, we use that tilde dot. Okay, so I'll say tilde dot, and then I'm going to say again the same thing, planned values dot root module dot resources, and then again the same type. I mean, you're going to filter it, and this is the thing. And yeah, this is the thing. So, but this is iterating over it. This is iterating. Now, the thing here is with this that it has went to, where is the type? I mean, yeah. Okay. AWS S3 bucket replication. Yeah, this is the type. Right. So now it is trying to go to iterate, right? So it is present here now inside this type. It is present in the inside here. I mean, the JSON is now. JSON is present where? It's present here now. Okay. JSON is present here now. All right. Now, if you go to the status, where is the status field? Status field is present somewhere here, and it is here. Where is the status field present? Status field is present inside my values. Inside the values, there is a rule array, and inside the rule arrays, there is status. So how I'm going to iterate over this thing? So since this is a child, so I need to do it something this way. Okay, so I'm going to say values dot rule is an array. So now filter rule such that status is equal to enabled. And again, same thing. We're going to check. This is going to return an array. And we're going to check this length. If this type of array exists, it means it should have length greater than 0. If it has greater than length 0, I want to return it as true. Right? So now this is going to return you an array, right? It's going to return you a rule array such that status is set to disabled, right? And if it is set, sorry, if state is set to enabled, if state is set to enabled, it's going to check whether this length of array is greater than 0 or not. If it does, then true is true, and it's going to give you passing checks. But since it has, let's try to do it something this way, enabled, right? Now our policy should eventually give us, or I can just do it like, I just try to copy paste good payload.json because you never know. Right. Now our policy has this thing such that status is set to, where is the status? Yeah, the status is set to disabled. Okay.
Just a reminder, we have 2 more minutes for this session, and we'll go ahead with another demonstration.
Yeah. So we have status set to is enabled, and I think this policy should work. Yeah, it's giving you passing checks now, right? Now if I set this to as disabled, if I set to as disabled, it's giving you failing checks. I can also have a message written, something like probably something message like set the status to disabled. All right, so it's the status has been set to disabled, and that's what you generate as. So you can also have a match block here. Like match block, what it's going to generate as if you go through the payload, you can find that the what it generally does is it's going to if match is not present, it's not going to validate your checks. So if match is set to true, then only the checks will happen. If match is not set to if match gets false, then checks won't happen irrespective of the fact whether checks exist or not. And what is this all thing doing? All thing is doing nothing. It's just like if you do any here, then it's going to check if any check exists, gives you pass, then pass the resource, pass the policy. All means all checks should give you pass, then only pass the policy. So that's how you generally write a policy. And yeah, I mean, that's how you write a policy and go through the JMS paths. I think those are very helpful resources. You can also go through the documentation, and also you can also join the Kyverno community that is on the Kubernetes Slack channel, and you can always ask your doubts. And the Kyverno-json CLI tool needs contributors. You can definitely go to this repository, go through, try to experiment, and just try to run it on your local system and explore it. So yeah, that was about Kyverno-json CLI tool, and we're pretty much excited what the future brings for it.
Sounds good. Thank you, Nitish and Faika. I know we're short on time, but those are really good demos and useful tips.
All right.
Okay, let's hand off to you, Khaled. Go ahead.
Yeah, thank you, Shooting. First, a shout out to you, Nitish and Vega. That was a good presentation. Thank you, guys. And now I'm gonna present performance regression. So, can you see my screen?
Yes.
Okay. All right. So, testing is an essential part of any software development lifecycle, and testing is not only for functionality testing. There are also performance testing. So one of the most known types of tests are the regression tests, which basically tests whether there is a regression in the functionality of the software or not as we progress in versions. What we did here is we have gone ahead and did the same thing regarding performance testing. So as you can see, I've introduced an artificial delay here in the resource handler. So basically the resource handler is the function that the entry function for every resource that enters the cluster. So if any resource is going to be applied to the cluster or created in the cluster, we are going to know about it through this validate function, through the resource handlers in general. So I've gone ahead and introduced an artificial delay. This should significantly delay the performance or regress the performance of the controller of Kyverno. And I've gone ahead and pushed this into a PR. I created, I pushed it into the repo and created a PR with it. And as we can see, we have added a new workflow called baseline load tests, which is failing. So as you can see, everything is succeeding. All the tests are succeeding. The conformance tests are succeeding because we have not regressed in functionality. But the only thing failing is the performance tests. As you can see, we initially supported two types of tests, which is Kyverno PSS and Kyverno Mutate. I haven't played or did anything with the mutate admission function, and that's why you can see the mutate tests succeeding here, whilst the PSS policies are failing. So let's have a quick overview of what the load testing does. So how do we load test? We are basically using as we showed in the previous office hours. We we briefed K6 and the performance testing, but I'm gonna go over them quickly again. So in K6, we are using a tool called K6, which basically does some tests over and over and over again quickly in a short span of time. It has different executors, and one of them he basically creates like a virtual users. A virtual user is basically an open connection, and it balances like a lot of iterations, a lot of requests using only these open connections. So and it performs the test like this. First, we deploy a Kyverno cluster where we deploy the PSS policies, post security policies, and then we create a pod that fails these policies, and we expect that it should fail. So as you can see here, we are generating a random pod. This pod should fail because it invalidates the PSS policies. Um, we send the request to the API cluster, okay, and then our controller should know about this, and it should respond with 400. 400 basically means that this request was denied, which is expected result. We deny the request because it doesn't pass the PSS policies. So this is basically the test, and I'm gonna show you how we run it quickly. I'm not gonna run it, but we basically create a script, pass the test script to it, and then pass the number of virtual users and the total number of virtual of iterations. All right, so here in the GitHub workflow, which basically is a CI workflow or a CI action, we are basically running the K6 node. K6 load tests. And not only that, no, we are also collecting CPU profiles and memory profiles. We have gone over these in the past office hours, but again, I'm gonna quickly show you how do we deal with performance regressions. So we collect CPU and memory profiles. We also do the load testing, and finally we get memory recommendations. So this part here is using VPAs or vertical pod autoscalers to get pod memory and CPU requirements recommendations. All right, so this is basically the gist of the test. Again, as you can see, we are failing the tests here. If and only if the tests fail, then we would have some artifacts, the reports themselves, and then we'd have the CPU and memory profile. So I've gone ahead and again ran the PR. I've downloaded everything, and then we can have a look at it here. So as you can see, we did the load tests with using 10 virtual users and 200 iterations. As you can see, we also in the test in the PSS tests, we add something called thresholds, which basically means that, hey, we expect that 90% of the requests should be below 200 milliseconds. So, and if you look here, the average duration of the test is 266 milliseconds, which makes sense given that we introduced an artificial delay of 250 milliseconds. So this doesn't pass the threshold, which makes the test fail. And as you can see, it's failing here only because it didn't pass the threshold. It's not because the pod, succeeded in getting into the cluster. No, all of them were denied. So what do we do now? Like, we know that we have regressed in performance. There is something bad. We introduced a bad change here. So what do we do? First of all, again, we would check why it failed, and then now we know that it takes too long. Why is it taking so long? That's a question that the CPU profile can answer. And to do that, we did this the last time, but I'm gonna do it again. So I've gone ahead and downloaded the CPU profile from the summary here, and then I can use the pprof from Go tools to profile the CPU profile. So we will do just that. It will open this UI for us, and if we go to view flame graph, we would have the flame graph, which again we described in the previous session. But let's have a look at it again. All right. So a flame graph basically means it has horizontal bars. Each bar's width or length is proportional to the time each function takes in executing the request. And if we search for validate, we'll find that All right, let me. Where is, yes, here it is. So again, if we look at the HTTP request, the time taken by the HTTP request, you'll find that this bar takes a lot of time. I've narrowed it down, but it takes a lot of time, as you can see, as is evident here. And if we go down this route, we'll find that the thing that takes most of the time is this one. As you can see, these are not taking so much time. This bar is taking most of the screen here, which means that this part is responsible for most of where the slowdown is. Again, you might be wondering, like, why did I focus down on this? Um, these are commutative, meaning that if any of these functions calls this function, it's in its stack, it's in its call stack, and thus the time of this is added to all the previous ones. So as you can see, this is the widest one where it starts to get narrower after it. So now we know that the validate function is responsible for this slowdown. We can go ahead, bisect the commits made in the past like week or 2 weeks, depending on the versions introduced. And then we can pinpoint what changed in this function and know how to revert this regression. This is basically a quick overview of the new CI and the pprof. We are kind of out of time, so I'm gonna stop it here. I hope this was useful.
Yeah, definitely. This looks pretty cool.
Thank you, Shooting.
Right. Thank you, everyone. If you have any topics you're interested in, hit us on Slack or GitHub and let us know. We'll talk about that in the next office hour. We'll see you next month. Thank you.